Hi, welcome back everyone. So in this video, we will directly go into the chapter 1 of SACE mathematical methods, which is on differentiation. So I will combine the chapters on differentiation and the application of differentiation in this particular chapter. So this will be quite a long chapter. So before we go into the idea of differentiation, we need to understand what is the idea of limits. So the definition of limits. This is a bit informal. Okay. So what is the definition of limits? So essentially this is the value of fx when x approaches to some value. Let's say I label it as C. So notation wise, we usually use the idea of limits as follows. So when x approaches to some value C, so what is your fx? So that is the notation that we will use for limits. So then what can it be used for in this particular SACE setting? So okay, what can it be used for? So primarily the idea of limits, you use it for to find the asymptotes. That's the first thing. Second thing is to find the derivatives. By using the idea of first principle. And the third thing is to find the integrals by taking the finite sum. So we'll explore the asymptotes and the derivatives by first principle in this particular chapter. And then for the integral part, we will study it in the next chapter. So let's look at asymptotes. So there are basically three types of asymptotes, but in SACE setting, what you really need to do is to understand how to find the horizontal and vertical asymptotes. So in SACE, you need to know how to find vertical and horizontal asymptotes. So what is horizontal asymptote? So horizontal asymptote is the value of fx that perhaps a better sentence is the value fx will approach when x approaches plus or minus infinity. So infinity is this symbol. So one thing that you need to take note is that your fx will never reach to that value. That's the core idea of asymptotes, whereby it doesn't matter whether this is horizontal or vertical asymptotes, your graph will not approach to that number. It will approach to that number, but it will never reach that number. So how do you find horizontal asymptotes? Identify horizontal asymptote. So by definition, the value of fx will approach to when x approaches plus or minus infinity. So by definition, you can just find this. You don't need to look at plus and minus. You can just look at one of it, and then you find the limits when x approaches either plus infinity or minus infinity. So let's say this is equals to a value of c, then your y equals to c is the horizontal asymptote. Alright, so let's look at some examples. So the simplest example is of course the reciprocal function, which is 1 over x. So we know that you have one horizontal asymptote and then one vertical asymptote. So let's not look at the vertical asymptote first. Let's look at the horizontal one first. So this is the graph for 1 over x. And you know that the horizontal asymptote is essentially your x-axis. So this is y equals to 0. How do you find that? Study the limit when x approaches infinity, for example, of fx. You find that this goes to 0. If you study, for example, x approaches minus infinity of fx, you find that this also goes to 0. But actually, if you look at the behavior of your graph, this goes to 0 through from positive side, whereas if you approaches negative infinity, it approaches 0 from the negative side. You can study this behavior, but I think essentially this is not really necessary, which is why I don't really talk about it here. So in actual scenario, you don't really need to study this in a theoretical sense. What you can do is, for example, you let x to be a very large number, let's say 10,000, and you find the value of f 10,000. So plug it in your calculator. 1 divided by 10,000, it is 0.0001. So then it means that this particular limit is true. So that's the fastest way for you to identify your horizontal asymptotes. So another example would be, let's say you have a slightly more complicated example. So this is 2x plus 1, x minus 5. So theoretically speaking, if you want to study the limits when x approaches plus or minus infinity, let's say we study plus infinity, what you need to do is to divide the top and the bottom with x, because you can't really directly substituting x approaches infinity just like that. But by doing so, you see that you end up with 1 over x kind of structure. So what you end up with is the value of 2 plus 1 over x, 1 minus 5 over x. So we already see that 1 over infinity approaches 0. So in the end, you will just get the value of 2. So the horizontal asymptote is equal to 2. Alternatively, you can let x to be a very large number, let's say 10,000. So f of 10,000 would be 2.0011. So this is approximated. So therefore, your horizontal asymptote would be y equals to 2. So the third example that you can do is to look at, for instance, x minus 1, x squared plus 1. So if you want to do it theoretically, you can study the limit when x approaches infinity. So this time, instead of dividing by x, you divide by x squared. So you have 1 over x minus 1 over x squared. So x squared divided by x squared, you get 1 over x squared. So this, when you let x approaches infinity, essentially this is 0. So of course you can also let x to be this value, and you test whether or not this is true. So you find that this is equal to 0.00009999, which is very close to 0. So therefore, your horizontal asymptote would be y equals to 0. So the example that I gave just now, if you study it carefully, this is a polynomial of degree 1. This is also a polynomial of degree 1. If you look at this particular example, this is a polynomial of degree 1, whereas this is a polynomial of degree 2. So in general, this method that I introduced here, when you want to find the when you want to find the limits by theoretical means, meaning that you want to divide everything by x or divide everything by x squared in the second case, it only works when your degree of the polynomial for the numerator is smaller than the denominator. If it is the other way around, meaning the numerator is a polynomial of degree 2, the denominator is a polynomial of degree 1, it doesn't work. So you need to be careful. Usually in the SACE exams, they won't ask those kind of questions, because what is important for you is to identify the horizontal and vertical asymptotes, which is why I don't bother to go into that particular case. So now that we know how to identify your horizontal asymptotes, we can go into the vertical asymptotes. Where is it? So what is vertical asymptotes? Vertical asymptote is the value of x that cannot be substituted into your function. So what are the examples? If let's say you have ln x as your graph, you know that x cannot be equals to 0. In fact, x cannot be negative, but okay, basically x has to be greater than 0. So in this case, you cannot substitute x equals to 0 inside the function. Therefore, the vertical asymptote is x equals to 0, which is why the ln x graph looks like this. Okay. Okay, let's look at the example just now. Your fx is 1 over x. So usually when we write this type of rational functions, we will write the value of x which cannot be substituted inside the function. This indirectly tells us that the vertical asymptote is just x equals to 0. So here you need to be a bit careful, because if you look back at your 1 over x graph, when you approach from the positive side, it goes to plus infinity, whereas when you approach from the negative side, it goes to minus infinity. So if you want to study the behavior, you need to pay more attention to this. So this is to study the behavior of your function around this vertical asymptote. So how do you study it? You study it by letting x approaches 0. So if you see the plus sign on top of your value over here, it means you approach 0 from the positive side. The other way around will be approaching 0 from the negative side. So if you have this kind of limit, it goes to positive infinity as shown in the diagrams. How do you verify it? You can substitute a value of, let's say, x equals to 0.001. So you can substitute a value very close to 0 but from the positive side. This is equal to 1000. So so this is what tells you that it goes to positive infinity. You can also study when you approach 0 from the negative side. You find that this is a negative infinity. So the way you verify it is to substitute a very small number close to 0 from the left side, which is the minus 0.001. Then this particular function with that particular x will give you minus 1000. So this tells you that when you approach 0 from the negative side, it goes to minus infinity. So of course we can look back at our previous examples. Let's just start a new page. So let's say fx is 2x plus 1 divided by x minus 5. So you know that x cannot be equals to 5. Therefore, your vertical asymptote is x equals to 5. You can of course study the behavior. So I will let you to do the substitution. But when you approach 5 from the positive side, this should be positive infinity. When you approach 5 from the negative side, this should be minus infinity. So you can test this out by substituting a... Okay, perhaps I just write it here. So the first one you can substitute, for example, 5.0001. This will give you a very large number. So this shows that when you approach 5 from the positive side, you get positive infinity. When you approach 5 from the negative side, you can substitute this particular value inside, and you find that this is a negative large number. So it means this is minus infinity. So let's look at our example over here. X minus 1 divided by x squared plus 1. Do you have any vertical asymptote? The answer is no, because x squared plus 1 you cannot be factorized further. So essentially you have all the values. So that's why for this particular example, you only have horizontal asymptote but not the vertical asymptote. So one final point is that if the function if the inverse function of fx can be easily found, then you can use the following. So the horizontal asymptote of f inverse is the vertical asymptote of f. So the vertical asymptote of f inverse is the horizontal asymptote of f. So vertical of f is horizontal of f inverse. Horizontal of f is vertical of f inverse. So why is this useful? Because as you can see, the vertical asymptote is very easily identified as long as those x values that you cannot substitute inside into your function, those are your vertical asymptotes. So if let's say you can't really identify your horizontal asymptotes in this case, what you can do is to use this property. If you want to find the horizontal asymptote of f inverse, you can just find the inverse function, identify the vertical asymptote of f inverse. That automatically will become your horizontal asymptote of f. So you can use this particular property to help you to identify your horizontal asymptotes. But of course, the other way around is to use your TI calculator. So you can use your TI to essentially plot the graph. Once you plot the graph, then you can also identify your asymptotes easily. So in your final exams, it depends on the number of marks given by that particular question. If the question asks you to identify the vertical or horizontal asymptotes and it is more than 1 mark, then you should write down all your steps for you to identify the asymptotes. If it is just a 1 mark kind of question, usually you just plot it by graph, by calculator, and then you just write down the answer. So hopefully that helps. Alright, thank you.